Hello everybody, my name is David Huey and my capstone advisors were Kate Lockwood and Sathya Narayanan, and my project was for the Naval Postgraduate School through Albert Barreto. So first, a little bit of background. The Independently Powered Command, Control, and Communications Project is a research project through the Naval Postgraduate School, and it's meant to support a city that may be affected by a natural disaster of some kind. And in that regard, it'll be able to temporarily host customer applications that can possibly support first responders and act as a support or even as a replacement for the Emergency Operations Center. So for one of these types of disaster scenario deployments, estimating the power requirements is complex in that there is no known clear method that exists to find these power requirements. And there's a lot of factors that go into estimating the power requirements, a lot of things that affect these deployments. Whether you're trying to run 10 computers or 20 computers, all of these things will change your power requirements and adversely affect what kind of equipment you're going to need to support what you want to have available for your deployment. My solution is to go out and discover these requirements by hosting a series of experiments that'll find the power requirements under different conditions and use that information to create equations that can be used into a prototype software that can easily estimate your power requirements and even suggest how you can go about accomplishing getting those requirements. So my methodology was first a series of deployment scenarios. I would set up, let's say, one computer just running at idle and see what the power requirements would be just to run one computer by itself versus, let's say, 10 computers connected to a server, connected to another router, hooked up to a satellite, and seeing what the power requirements would be for that. And under these different activities that the computers and different devices undergo, including remote desktop or a Skype video call, I would find the different power requirements. From there, I would run these experiments for approximately an hour and find an average over the poles of how much power is required and convert them into equations which I would put into software that I developed in NetBeans, which is an integrated developing environment for Java. There's a few screenshots of the software. In the first two screens on the left, you can see that it'll ask you questions like what kind of applications do you want to use in your deployment and what kind of computers are going to be used in the quantity. And by pressing next to the final point, you can see, based on my experiments, you can see what your approximate power requirements are and the types of equipment, like one flexible solar panel and one hybrid solar panel can achieve this. Some of the tools I use for virtualization and a lot of the IPC3 project components, and also software, Java, and NetBeans. One thing I learned is time management. Given that I was doing each of these deployments over the course of 1 hour, and it's a lot of different scenarios, you can't really just do all this last minute. You have to plan out a lot of it. Java and NetBeans, I've never programmed in Java before, so this was a little bit of a leap, but not too much. And GUI development, again, I've never developed anything in a graphical user interface before, so this was definitely a first for me. Thank you for your interest in my capstone, and come visit me in my poster session in room 160.